So before we talk about graphing, I want to make sure we're clear on how to use this notation. Okay, so let's say I have this function f of x here, and I want to know what is f of 2. Right? Well, you know how to do this in principle. You put it into the formula part of the function, and then just simplify it. But here we've got this big question to answer: which formula do we use? All right. Well, the way you do that is you take this x value and you compare it to these ranges over here on the right hand side. Right? Is 2 between -2 and 1? No, it's not. Is 2 between 1 and 3? Yes, it is. So this is the formula that I'm going to use, and I'm going to say f of 2 is 2 squared, which is 4. Right, so let's look at another one. Let's say I ask for f of 1. Okay, well, I'm going to do the same thing. Right, is 1 in this first range here? Well, yes, it is, because this is less than or equal to. So that one includes 1. So f of 1 must be 3 times 1 plus 1, which is 4. All right, let's try one last one before we go and try to do some graphing. What is f of 3? Well, let's go through our questions again, right? Is 3 between -2 and 1? No. Is 3 between 1 and 3? Well, that's less than 3, not less than or equal. So no, it's not in there. And then if we come down here, is 3 greater than 3? Well, no. It's not in that range either. So if you look really carefully, there is no equals here with the 3. So this function is not defined at that value. So I would say f of 3 is undefined. All right, so with that said, let's talk about some graphing. So I have a basic piecewise defined function here, right? It's 2 lines, right? 2x plus 1 is a line and -x is a line. And I have split this into 2 parts, and the dividing line is going to be at x equals 0. So I expect it to look like one thing to the left of 0 and another thing to the right of 0. All right, so let's try graphing this and see what we get. All right, I know the y-intercept of this thing is 1. That's going to be right here. And it's got a slope of 2. Right, so it's going up like this, something like, and it's going down like this. If you're part of my very sketchy artistic skills. Now, I don't want all of that, though. The function only looks like this for values of x that are less than or equal to 0. That's everything from here to the left. So what I'm going to do is I'm going to literally, if you're doing this in your notes, hopefully you're using a pencil, you're going to take your pencil and erase everything that is not in this range of y values. I'm going to take away this whole side over here. Right now, I'm going to do the second part, right? -x, that has a y-intercept of 0 and a slope of -1. So it's going to look like this, more or less, and it's going to go up this way. Right now I've got the same thing going on here, right? It only looks like this for positive x values, right? Those are the values on this side. So everything not on that side, everything to the left of that needs to go away. So I'm going to get rid of this part. Right, now one last thing we have to do here is think very carefully about, whoops, sorry, I just took away too much. Let me put that back. There we go. Oh, come on, my stylus is being a little difficult. There we go. And the color changed, that's okay. When x is equal to 0, we're supposed to use this function. So f of 0 is 1. So I'm going to put a filled in circle here. Now down here, this downward angling line, x, the function is not 0 here. So I'm going to put an open circle there. to show that that the endpoint of that section isn't part of the graph. And that's it, right? We can get rid of all my little notes down here, my little extras. And that right there is the graph of this function. So now let's take a look at this one, right? It's a little more complicated. It's got 3 parts instead of 2. But we're going to handle doing this graph the exact same way, right? First, I'm going to look at the first function up here, 3x plus 1. And that's a line, right? It's got a y-intercept of 1, and it's got a slope of 3. So it's going up pretty steeply here, and it's going down pretty steeply as well. Okay, now look at the range, -2 to 1. So -2 is here, and 1 is here. This function only looks like that between those x values. Anything outside of that, like this piece down here and this piece up here, has to go. Right, now what do I do about my endpoints? Well, I have strictly less than here, so that's going to get an open circle. And I have less than or equal to here, so that's going to get a filled in circle. All right, and that's the first part. Good, now let's do the second part. Between 1 and 3, this looks like y equals x squared. That's a parabola, right? And let's see, it's a parabola that looks like this. It goes through 1, 1, and it goes through 2, 4, and then continues on up from there. And it also goes to the left. And that's not very pretty. But we're not going to use it anyway, right? Because we only want between 1 and 3. Everything outside of that, I'm going to erase. So this part is going to go away, and this part, and then I'm going to lose it all here, but I'm going to keep this going. This should be 9, right, which is right about up here. And I'm going to put open circles at both endpoints because I have strictly less than on both of these. All right, and then finally I got to do the square root of x. And I know I'm going to start at 3. Right, well, let me just draw the whole thing, right? Square root of x looks like, what is the square root of 3? That's 1.7 something, right? So it's going to be going kind of like this, okay? And I only want the section of this that is greater than 3. So this part gets to stay, and everything else goes. So I'm going to lose this part here. I'll put a little bit of that back. And this is it, right? I've got strictly greater than here, so I'm going to put an open circle, and that is what my graph looks like, right? 3 parts, and none of them connect, right? None of them are going to match up with each other, and that's fine, right? Sometimes that's what these graphs look like. So in the next series of lectures, we're going to look at something called transformations. Right, and that's another graphing tool. And in this lecture, in this part of the series, we're going to use that primarily as a way to get the graphs of functions. But you really need to kind of file that away because it's going to come back later on and be really useful when we talk about exponential functions and logarithmic functions.